Okay, I'm going to explain how to derive the Pythagorean identity. But before I get to that part, I need to explain the relationship between sine and cosine. Both are defined by the lengths of the sides of right triangles. Sine is equal to the opposite side length over the hypotenuse side length, and cosine is equal to the adjacent side length over the hypotenuse side length. So, when I consider this triangle here, I can say the sine of theta equals a over c, because sine is equal to the opposite side length, a, over the hypotenuse, c. I can also say the cosine of theta equals b over c, because cosine is equal to the adjacent side length, b, over the hypotenuse, c. Alright, let's go in here. Let's consider a right triangle with a hypotenuse of 1. When I do this, I can say the cosine of theta equals a over 1. Why can I do that? Because cosine is equal to the adjacent side, a, over the hypotenuse side, 1. And when I solve this proportion, I get a equals cosine of theta. I can also say that sine of theta equals b over 1. Now why can I do that? Because sine is equal to the opposite side, b, over the hypotenuse side, 1. When I solve this proportion, I get b equals sine of theta. Well, now that I know a and b, I can replace them with cosine of theta and sine of theta respectively, which I did right here and right here. Alright, next step. I drew an altitude on this triangle here, and this does two things. It'll split my hypotenuse in two, and it'll give me two triangles to work with later. I'm going to explain the hypotenuse stuff first. I'm going to call this part of the hypotenuse x, and this part of the hypotenuse y. And from that, I can say x plus y equals 1, because when you cut something into parts, those parts added together will equal the whole, and the whole in this case is 1. So that's where I get that. That'll be important later. Alright, now I am going to look at these triangles here. Now, where did I get that? I got that triangle from drawing this altitude. It's this part right here. Alright, I'm going to write a proportion for these two triangles, and that proportion will be the cosine of theta over 1 equals y over cosine of theta. Now, here's where I get this stuff. Cosine of theta over 1 comes from here. If cosine is equal to the adjacent over the hypotenuse, then it would be the cosine of theta over 1. That's where I get that. Now, for the y over cosine of theta, like I said, cosine is equal to the adjacent, and that would be y, over the hypotenuse, which is cosine of theta. That is where I get this proportion. Now when I solve it, I get y equals cosine squared theta. Alright. Now I'm going to come down here and compare these two triangles. Now, where did I get this triangle? I got it from here. This is this triangle after I drew that altitude. I'm going to write a proportion for this one too. Alright, the proportion I get is sine of theta over 1 equals x over the sine of theta. Alright, here's where I got that. For the sine of theta over 1, it comes from over here. Since sine equals the opposite side length over the hypotenuse, you can say that the sine of theta, which is the opposite, over 1, which is hypotenuse, and that's where I got that part. Alright. I got the x over sine theta part from this triangle here. Like I said, sine equals the opposite, x, over the hypotenuse, sine of theta. That's where I got that. So, when I solve this proportion, I get x equals sine squared theta. Alright, well I know x, and I know y, and I can plug that back in the equation I made earlier. So come over here, x plus y equals 1. So, x equals sine squared theta, so there's that, and y equals cosine squared theta, there's that. Thus, sine squared theta plus cosine squared theta equals 1, which is the Pythagorean identity.